Unfortunately, no one, like every single one of the notes that you guys have seen all year, unfortunately, and I say this sincerely, unfortunately, was simply me doing it. No one vetted any of these. And so I feel okay that the mistakes are only like very occasional, but if they're there, they're there, and I'm okay with fixing it. It's totally fine. So maybe it's, if you just replace all of the 1.963s with apparently 1.904s, that'd probably change the answers slightly as well. Oh, you know what? Now that I look at it, I think the error probably had to do more with me reading my own writing, because when I look up there at the graph, that 0, it could go with a 0 or a 6 right there. It looks like I just didn't complete my 0 all the way. I'm guessing that's probably what it was. So, anyway. So let's just go through the magic of technology. 0, 4. Hey, listen up. Hey guys, how are we doing conceptually, right? We can make sure that we get the 1.904s in the world correct, and we want those to be correct. But the biggest thing, of course, is what is your integrand like? Do you understand where those limits of integration even come from? Stuff like that. Let's talk about that. Ty, go. Part B.
I don't necessarily understand like the -1 minus.
Okay, yeah, sure. So I'll show you. If you haven't already watched the video from Monday when you were gone, there's going to be a similar discussion here. I would encourage you to master that video. I'll do something similar right now. So the first set of parentheses is big R squared, right? It's the bigger radius. So here is how I presented this more or less the other day. I said that the big radius would stretch from the axis of rotation to that further away function. And that, of course, would be the exponential out there. So would it be fair to say that the big radius is the yellow line segment? So then you stop to think, well, this yellow line segment is going to be a totally different length depending on where you draw it, right? It's going to be shorter or longer. So instead of being able just to say, Brendan, that's a distraction.
Sorry.
Thanks, man. So instead of just saying, hey, the radius is always 5 or 4 or 6 or something, we have to admit it's going to be different depending on where we are. So we have to write an expression for it. Here's what I would say. This red line segment, isn't that a part of the radius? Okay. And then isn't the other part of the big radius this green line segment? So wouldn't it be fair to say that the yellow line segment is equal to the red line segment plus the green line segment? Okay. So I'm just going to come over here and say something like big R, big radius, equals 1 plus, couldn't you define the green line segment as basically just a y value? Like from the x-axis up, that's the definition of y. So you could write this. That would not be a very good place to finish, though, because isn't it a dx representative washer? Or I'm sorry, yeah, for B is washers, yeah. So I can't leave it like that. So for this function out here, y equals what? Isn't it right here? So I could write r equals 1 plus 3 plus 2 to the negative x. Well, we're going to come back around to that in a second. All I'm asking you to do is think about the geometry of it. Does this geometry make sense? Okay. Because isn't the distance from -1 to the x-axis 1? We're talking about distances here. So you are not, in fact, you've seen it here. I typically don't write it this way because for me, I feel like if I can kind of formulate it a little bit, like understand where it's coming from, but if I can formulate it and be efficient, that's what I'm going to do. So what I wrote essentially for big radius was this. R equals -1 minus 3 plus the quantity of 3 plus 2 to the negative x. So I'm getting that from right there. So then, gosh, somebody could look at this and say, well, this black expression is 4 plus 2e to the negative x. The purple expression is really -4 minus 2 to the negative x. How on earth is that the same thing? So that in of itself is not the same thing. But what do we do to the big radius and the little radius? Square them. So one of the unique features, of course, about squaring something is you just multiply it by itself. Hang on. So, yeah, if the distance is -5 and you square it, don't you get 25 still? Whereas if you did 5 squared, so like what I'm getting at is -5 squared is 25, and 5 squared is 25. So whether you do -1 minus or you do all that geometry and you're like, well, really, it's the red plus the green. No matter how you do it, because you're going to square it, as long as you do it correctly, it's going to end up being the same thing. So what I do, to be honest with you, is I will always try to do it the same way, and that is I'm always going to go axis of rotation, which is -1, minus whatever the appropriate expression is. Because I know I'm about to square it anyways, so it's all good. Does that make sense?
Yes.
Okay. Other questions on A, B, or C? Hey, listen, I just want to check with y'all. You can tell me what you think. Are you guys okay with the integrand on number 1?
Yes.
Do you understand why the area of this rectangle happens to be 2 base squared? Okay, I just want to make sure. We talked a lot about that. Can you see? We talked a lot about this in the other class. Drew a picture. Somebody asked why it was, f minus g squared. I wrote that out. You all solid with that? Okay. So for those that are kind of itching to get on to number 2, I do have one little thing with number 2 to fix for you, and then just a piece of advice. So this is really, really strange. Oh, now that's even weirder. No. There we go. So, there we go. That's what I want. So look at number 2. Flip over to number 2. Do you see how in B, look at your B. Do you see how mine says if region M is, hey guys, this is where not being focused is going to totally screw you up. So listen, and then you can go back to your talking or whatever. So in B, it says, rotate the region M around the vertical line x equals 4. I think yours says y equals 4. It should say what mine says. And I don't know how, because all I do is I take this PDF and dump it into Schoology, so I don't know. I must have gotten interrupted like mid-edit. What? B should be x equals 4. And yours says y, right? Right? Okay. So there's that. And then a piece of advice. So some folks in the other class were working on this one, and they realized that they needed intersection points here. So I got 2 things to say about that. Number 1, if this happened to be some quiz question, I would probably just give you the intersection points. Is that really calculus for you to find intersection points? That's iffy at best, right? And then, so I normally would give these to you. And then number 2, it's just class. We're just kind of playing around with this, so I thought I would give you the opportunity to find the intersection points yourself. Here's how you do it. Use your calculators. And you basically take both of those expressions right there. Do you see how it's x in terms of y? What you do is you use your calculator. You plug them in as y in terms of x, because isn't that what your calculator wants? So basically you're just like swapping all the x's and y's. Find the intersection points, and then what should you do with the intersection points? Swap them back. Get it? That will allow you to find the appropriate intersection points here. And the numbers and the scale should all make sense. Play around with it. You've got about 12, 13 minutes. And once you find the intersection points, I'm hoping that most of these will go pretty smoothly for you. So check it out. See how it all goes.
So we take the x instead of taking the y?
Which equation is?
I'm not sure what you mean by take.
So I'm looking for the intersection point. You said switch it back.
Yeah, so like, let's say you graphed it y in terms of x, let's say one of the intersection points, sure, let's say one of the intersection points was like 2, 1.
Yes.
Let's just say that's what it
Well,
was.
actually,
Then on your paper, you write 1, 6.
Okay.
So do you see how, you see how this intersection point, the sharper one, goes with this?
Whatever the intersections are,
So find that intersection one.
Swap it though.
Yeah, you have to, it makes sense to graph. So like, you look at this, one is gonna be like, basically, roughly like 0, 0.75. So make sure that it actually makes sense.
But this one I should actually swap.
Yes, that one too.
Well, because X is equal to 2.
Where the intersection
Not
of
1.6. Oh, I guess X and Y is.
So y is, you see what I'm saying? You're just doing both.
Thank you.
Yep.
So negative 2.90.
No, I already took this.
Oh, you did? So, 1.6.
This is one of my lotus sign questions.
No, it's not negative 2.
Yes, sir.
Something like number 1 over there. I'm like, what is if we go like -1 minus x minus 1 minus g of x, would that be
Okay, wait, what's the
okay?
1.6?
Well, how's that any different than what I wrote?
No. Like,
Oh, if you wrote
Yeah,
f of x and g,
instead of-
totally fine.
Okay.
In fact, recommended.
Oh, okay.
Yep. Just from a time and space perspective, why wouldn't
So I
you?
would have done like points off if I did something.
Definitely, as long as those functions are defined and
Yeah.
they're over there, yeah,
Okay.
totally good. Hey, for those that are working quickly here, I'm also going to be handing back your Unit 6 tests to the seniors who have not had a chance to see these. So once you feel like you're done, check out your test from Unit 6. You're welcome to do so. Taylor, you have not seen yours either, right? No? Ty, what was your question?
Oh, I was just gonna ask to make sure I did the check.
You say a little loud. Oh, you're asking if something's right?
Yeah.
Okay, I'll come around in a second. I'll get these tests from you back on the way out, but I thought I'd let you check them out, especially if you're done.
You do this minus this. You do
TV,
Okay, well, I know. Okay, and I know you don't. So, not when my
Right?
phone comes
And then-
in screen to
sorry, read there is your Unit 6 test. Joey, there is your Unit 6 test. You want to check that out? Brandon, here is your Unit 6 test. Will, here is your.
I like
Yeah, I got it too.
Ty, here is your Unit 6 test.
I did the same thing as like, yeah.
Oh, sorry.
I was times 10 is not.
That same negative mistake.
Yeah, it's the absolute value, right? So. you can have the
I know I can check it, so yeah.
Nice, dude.
So bad.
It depends on what y it is.
Because this is 1 minus negative. So it was just make this side negative.
Yes.
I don't know why, I get that now. It's your test. Wait.
No, D is the unit. So it says A, B, and C, area, and area is never negative, so that's what you each. Carefully worded, it's not easy, but it's carefully. I don't know, mine was on Here in about 2 more minutes, I'll put up the answers for our practice. Question. You had a question about something you
No mistakes.
Oh!
It doesn't seem to be too
Well, 9 plus 6 is
Try hard. I got an 88.
I'm ridiculous. This literally has.
Last poll, I got 8.0. I got that.
Five. That's right, but you don't Oh, I forgot
Way harder than I thought it was.
Say that.
So this is like
Never mind. I'm kidding. Everything I
What do I do?
I was about to like no, because I didn't.
Because on the
It's just something.
Hey, let me show you some answers.
No, like
I hope my little decimals worked out better this time. Here you go.
I'm sorry.
Is that the same point?
725. Point. Nobody got upset with my numbers in the last class, but they didn't get upset with the 1.904 like you guys did.
I read on the very last one and see, I read it 728 and I got really confused. Yeah. And now we're just trying for the bounds on the Enneagram. I put 0.728, so that's fine.
You can check it out if you want. Yeah.
This quiz is tomorrow.
I got
Okay, yeah, hey guys, listen up. So Allie said for the very first one, she basically, you got the integrand flipped around? Am I correct?
The input. So basically I did the negative y plus 9y was for the...
Yep, gotcha.
It doesn't matter.
Okay.
The square, it doesn't.
So I would say in the end, because you're going to be squaring it, like functionally it's not going to matter, but let's make sure we have it right. So I don't know, maybe I just I'm guessing whether I have it the same order as you or not, I'm guessing I looked at it and said I'm about to square it anyway, so I don't really care.
Okay.
But to be clear, well, I think, hold on, isn't this would really matter for area, right? Isn't this the parabola right here? And then this is the trig.
Oh, yeah, I have that written down, and then I got myself.
So I think if we want a positive side value, I think we'd have to go purple minus red.
Yeah, okay.
But because you're about to square it, even if you did red minus purple, it wouldn't matter. It'd be kind of nice in this case.
Yes. Okay, so that makes sense.
You zoom out so I can see you. You gonna pull it?
Which one you said so I can see what?
See, if I would have known that.
I have had the other way for that one.
I got.
That's what's nice about.
So hey, listen, Anna. Hey guys, hey, can I get all of your attention? I know Anna just asked a question, but I want all your attention. So I want to let you know kind of how the next couple of days are going to go in our class. Tomorrow, when you come to class, what we'll do is I have a review set for you for the first 25 minutes or so. We'll do a review set over, guess what?
This.
Volume, right? And then your quiz will be in the second half. Keep listening. Those of you that are talking are probably not listening. I just want you to hear this. Next Monday, Tuesday, Wednesday, I think I have this right. You can look at your calendar for sure. They're all review days. And during the second half, the last 25 minutes of all those classes will be opportunities for retries. Okay? I'll still do the morning thing or the other times or whatever, but we'll just reserve the second half for you to do a retry. Okay. Anna, super quick.
Yeah.
Do you see how this is further away? Wouldn't that be the bigger radius? Hang on. It's not right and left, it's further away or closer.
And it, okay, I see, yeah.
Hey guys, I'll get your test from you on the way back out. Your unit 6 test.
You're like, that's your
Marlene was like, all right, we're just gonna take friends. He's like, I think I should.
Yeah, I was looking at him.
Thanks, Mitchie. I appreciate it.
Tyler, thanks for reading. Thanks, Jody. Mitch, have a good day. Thanks, Cole. Appreciate it.
Thank you.
Hey, this is a pretty good one.
I was shocked. I was absolutely shocked. I would love to go over the ones I missed, because I felt really bad about a couple of them afterwards.
Well, the thing you felt good about is good.
Thank you.
So let's focus on those other ones.
Yeah, for sure. Thank you.
Thank you, Blake, for bringing us today.
I need to rest.
Oh, goodness.
You made it.
Yes.